Hi, now let's discuss about the principle of operation of various instruments for monitoring patients' biological parameters. So now we want to discuss about the sensors, type of sensor, especially thermal and mechanical sensors. So first, thermal sensor. The first thing I want to discuss about is a thermocouple, which uses a fuse we call bimetal, meaning like two metal put together. Fusing two dissimilar metals actually produce a voltage difference with temperature of the junction. And that is called the thermo generating, producing electricity by difference of temperature. So that's thermoelectric effect. And that looks almost like this. So you see these two metals with a junction, so two different dissimilar metal wire, and you give a heat compared to the cold, then this generates a voltage difference. So an industrial product looks like this. So this is a shielding with the stainless steel. So you can see this red and blue metal wire, and they have a junction, and that junction is a sensing point, and it will generate voltage. So this one is suitable for measuring over large temperature difference, such as up to several thousand degrees. And so on the other hand, it's less suitable for where very small temperature differences need to be measured with high accuracy. So that is less likely, and this application is more like heating appliance. So, you know, if you have a heating appliances such as rice cooker at home, and it's likely that this thermocouple has been used. And the second is I want to introduce this so-called RTD element, which is resistance temperature detector. So these RTD are sensors used to measure temperature based on resistance changes with temperature. And how does this RTD or resistance temperature detector looks is as a very fine wires wrapping around a ceramic or glass core. So here's the two examples with this ceramic, very fine wires wrapping around. So when the temperature changes and these substrate thermal expansion will affect the wire, and then it can be used for the temperature changes sensor. So this one is a platinum thin film layer with on the ceramic substrate, and there's a lid. So this RTD or resistance temperature detector wire is usually a pure metals, typically platinum, nickel, or copper. So this resistance temperature detectors working on a basic correlation between these metals and the temperature. And so it looks almost like this ceramic, and this is a thin film. And so let's see this actual data. So when the temperature rises, thinking about this, the relative resistance also rises with different platinum, copper, and nickel. So as the temperature element increases, the electrical resistance also increases. So this is my my theory on this. So that ceramic or glass substrate will thermal expand when the temperature rises. Then this is a very thin wire will also elongate. So the diameter or cross section goes down, so the resistance will goes up. The third one I want to discuss is thermistor. So thermistor means a thermal plus resistor. So that's a temperature sensing element with a resistance varying with temperature. And usually it is a little different from RTD resistance temperature detector, that this has a negative temperature coefficient. And that's because it's made with a ceramic or polymeric polymer materials, not the pure metals like RTDs. So it looks almost like this, very simple. How we operate them, I give you an example here. So that these are thermistor, and we have a resistance, and this is a op-amp with a follower, and to measure the voltage to analog to digital converter as an input. So this needs a circuitry that you see this thermistor. When the temperature changes, this resistance changes. And you see this voltage reference, and this RT and this thermistor resistance is a voltage divider, and that you measure it with this voltage follower. So the basic operation is resistance change is supposed to be related to temperature change with a constant as a first order. So look at these data compared with RTD versus thermistor. You see much large resistance changes. You can see, so it has a higher higher gain or sensitivity, and also the slope is opposite. So when temperature rises, these thermistors resistance actually goes down. And as a note that typical resistors, which you don't want it change its resistance over time. So these are designed to have K as close to as 0, but in thermal sensor or thermistor, you want the K as big so that it can be more sensitive. So to describe this, people have developed this empirical formula too. And you can, at a certain temperature, you can always normalize this by Taylor series expansion, and you can make a linear approximation. So let's compare these various thermal sensors, and I note here what's worthwhile to note, and thermocouples and resistance temperature detector, resistance thermal detector, and thermistor. And thermocouple is can measure wide range of temperature, but while it's nonlinear. Let's see the data. So thermocouple, you see it's a little bit nonlinear. And RTD is more stable, very good linearity, and the most accurate. While it requires a pure metal, so it's costly, and the manufacturing is difficult, so it's costly. And while thermistor is a very quick, fast, based on the sensing element as a polymer, while you can see the range of temperature limited, and itself is a nonlinear response. So there's another comparison chart for range and accuracy, linearity, and sensitivity. You can take a look.